Hello, we're going to be going over the Spring 21 final question number 7. The first part A, we're going over the analysis phase of recovery, and we've recovered the following log from the disk when recovery begins. The first part asks which of the pages are in the DPT, or the dirty page table, at the end of analysis. So in order to analyze this, we'll just start at the top of our log and build our DPT. So we start off with the master record LSN 0. At LSN 10, T2 is updating page 2. So page 2 is going to be in our DPT. And just for our sake right now, we'll just keep track of the fact that T2 was the last one to update that page, or was the one that changed that page. Next, T1 updates P1. So P1 is going to be in our table. T3 then updates P3. So page 3 is going to be in our table. Next, we start committing T2. Notice commit at this point does not mean that any of the changes have been flushed to the disk. It's just announcing its intent to commit. So it's starting the process of flushing the pages and flushing its changes. T1 updates P1. So P1 is still in our DPT. Then T2 ends. Now that T2 has ended, the page that it had modified, page 2, is now been flushed to the disk. So we can remove it from the DPT. But now T3 updates P2. So P2 comes back into the DPT, but it's T3 that modified it this time. Then we decide to abort T3. Again, we don't remove it from the DPT at this point. Then T1 updates P4. So we add that into our table. So that means that the pages that are in our DPT at the end of analysis is page 1, 2, 3, and 4. What is T1's status at the end of analysis? So at the end of analysis, that's looking at the log that we have right here. The last record that T1 had was an update for P4. It's not aborting. It hasn't decided to commit. It hasn't ended. So at the end of analysis, if there are any transactions that are still running, we decide to abort them. So that means that it will be in recovery abort. What is T2's status at the end of analysis? At LSN 60, T2 ended. So now that T2 is over, it no longer exists in our transaction table. It's completed, any changes it made has been flushed to the disk, and all of its changes have persisted. So at that point, we would just say T2 is not in the transaction table because of the end T2 record that we see. Looking at question 4, is asking T3 status at the end of analysis. So at the end of analysis at LSN 80, T3 started to abort. Notice we don't have a T3 end record, so we don't know if it has updated the changes that it has of the abort, if it has completed or made the changes accordingly. So we just say that T3 is in recovery aborting at the end of analysis. Part 5 says, in the log that we recovered from the disk contains records that have been flushed prior to the crash. However, there may have been records that were not flushed. Which of the following is a plausible set of log records for T1 before the crash? So if we're looking for records that could have been executed and been there, but were not flushed to the disk prior to the crash. So looking at this first one, we just have 2 more update transactions, and that's perfectly viable. There could have been other updates to other pages that we didn't have flushed to the disk, so we're not able to see them in the analysis phase. So this is a possible answer. The second one has T1 committing and then ending. Now remember when we said prior in this question, now that T2 has ended, any of the changes that it made on its pages and it committed, any changes that it made has been flushed to the disk. In this situation, since T1 has committed and T1 has ended, all of the changes that T1 made to the pages, we expect them to have been flushed to the disk already. But we see in our current DPT and in our transaction that that's not possible. It would change the status of our transactions. So this is not a viable answer. Again, to clarify, if it had committed, we would have expected to see the log records have been flushed to the disk because that's part of the commit process. And the fact that it ended tells us that that must have happened, but we don't see that in the log record. which tells us that T1 committing and ending is not a possible situation. But for T1 to have just aborted, that's possible. Abort does not mean the records need to be flushed to the disk, so this is a possible answer. T1 could have aborted and then ended. This is also a viable answer. The abort record happening and ending does not have any requirements for those records being flushed to the disk. That's only for the commit transaction. Once it is ended, we need those updates to be flushed to the disk. So having the fourth option is also a viable answer. All right, part B is looking at the redo portion of recovery. The first question asks, what LSN does redo begin at? This is from our notes. The redo will begin at the lowest rec LSN. That we will go to the DPT table and we see that's 50. So that means that our answer for the LSN that redo is going to begin at is 50. Next, we need to select the LSNs with all the operations that are redone during the redo phase. For the redo phase, we will begin at the checkpoint and we will redo any updates and CLRs. So that means we will need to redo LSN 50, 60, 70. We'll need to redo 110, this update, and we'll also need to redo 120, which is a CLR. So that would be 50, 60, 70, 110, and 120. Notice that we start at the checkpoint, the begin checkpoint, and then work our way down. We don't consider anything higher than that begin checkpoint. In part 3, we have that at LSNs 40 to 80, we performed a fuzzy checkpoint. So which of the following are possible transaction tables stored in the checkpoint table? So we're doing fuzzy checkpointing from LSNs 40 to 80. Remember, 40 is where the begin checkpoint is, and 80 is where the end checkpoint is. So right off the bat, we know that we don't expect to see any LSNs which have a value less than 40, because that would violate our checkpoint properties. That eliminates this first question for us, or this first option for us, because of this LSN 20. Next, we'll look at this one, which has T1 running with the last LSN of 50 and T3 running at the last LSN of 60. What seems to be missing is T2. However, this is okay because T2 starts in the middle of this checkpoint. Notice that these LSNs prior are not having to do with transaction 2. So the first record that's associated with transaction 2 is at LSN 70. And it's completely possible that we didn't have transaction 2 starting yet, so we didn't need to include it in our transaction table at that checkpoint because of the fact that we're doing fuzzy checkpointing. Some information could have been dropped in between of the begin and end checkpoint. The next one has T1, T2, T3 with 50, 70, and 60, which are the 3 updates that happened in between at the begin and end checkpoint. And this would be the ideal situation. We have all of them updated as we expect them to. So this is possible. The last one has T1 with a last LSN of 90, and then T2 and T3 with the last LSN of 70 and 60. The problem with this particular option is this last LSN of 90. Notice that the end checkpoint is at LSN 80. So we would expect that the transaction table here would not have any LSNs greater than that end checkpoint value of 80. So because of this LSN 90, we would eliminate this option. So the only 2 viable ones are the middle 2 options. Part 4 is asking what's a possible reason why P3 or page 3 is not in the DPT when we begin analysis, even though it was modified at LSN 30. So the reason why pages are in the DPT is because a change has been made to that page, but that page has not yet been flushed to the disk with those changes. So if P3 is not in the DPT, even though it was modified at LSN 30, it's probably because at some point it was flushed to the disk for whatever reason. And so it no longer needs to exist in the DPT. That's the only reason why we would expect for P3 not to be in the dirty page table. So the answer here would be P3 may have been flushed before the checkpoint. Part C is going through the last portion of our recovery, which is the undo phase. We're given the log, transaction table, and DPT. And we're asked which of the following LSNs are in the initial priority queue. Remember that the undo operations work backwards. They start with the last LSNs of the transactions that are in the transaction table, and then they keep filling up the priority queue with the next LSN that happened previously for that particular transaction until the value is null. So that means we'll start off a priority queue with the LSNs of 110 and 120. And then using 110 and 120, we'll keep filling them up with like 70 and 100 using this previous LSN field that we have in the log. So for part I, or part 1, we will have a 110 and a 120. Part 2 asks which of the following records are undone. So the records which are undone will be all update records. Remember, CLRs are not undone. We don't want to undo those ones. We just want to redo those. So any update transactions that relate to the transactions that are currently in our transaction table, which would be T2 and T3, are going to be undone. So that's at 110, we have an update involving T2. At line 70, we have an update involving T2. Line 60 or LSN 60. And then we have another one here at 30 and 20 involving T3. So you have 20, 30, 60, 70, and 110. 20, 30, 60, 70, and 110. Those are the records that are undone. Notice, even though we had a CLR involving T3, we don't undo it because we don't undo CLR records. And that's all for question 7.